up. Well, the angles make a difference. Alpha Z times 496.93 at an angle of negative 84.48. 48.24 at an angle of negative 150.58. So what I'm going to do is I'm going to add these two numbers together and make sure that it adds up to 30 at 15, because these look a little crazy. So that one plus 77.65 at an angle of 23.90 equals 29 at 15. You see it here. So that's pretty close. So that makes sense. This circuit is good. So now we can go back to the next one. So once this circuit makes sense, and it does, right? Everything added up, looks good. Let's do this. Okay. We're going to go back to this circuit, right? So this number here, this 496.93, is actually here. Okay, let's move this down a little bit so you can see it. This we got because we did a parallel combination. What's constant in parallel? Voltage. So this voltage from here is going to go back here and here to get their currents. And their currents must add up to where it came from, which is this guy. So their two currents have to add up to 97.07 milliamps at an angle of negative 66.10. So let's do that. 48.24. I'm just do it over here. 48.24 at an angle of negative 150.58. That voltage for that. And 48.24 at an angle of negative 150.58 here. So see, I put those two voltages here because they're in parallel. So now let's get their currents. So 48.24 at an angle of negative 150.58. I'm going to save that. Oh, go back. Alpha Z, I'm going to save that. So alpha Z divided by 500 at an angle of negative 90. So I got 96.48 milliamps at an angle of negative 60.58. So that's the current for this guy. I'm going to do the same. 5.161K at an angle of negative 0.89. So that's crazy. That cannot be. Oh, I did multiply. I knew there was something wrong. I hit the multiply instead. Divided by that is 9.35 milliamps. So this one is 9.35 milliamps at an angle of negative 149.69. So those two currents add up to where it came from, which is 97.07 milliamps at an angle of negative 66.1. So let's add these two up and make sure it does, in fact, add up to where it came from. 96.48 milli at an angle of negative 60.58 plus 9.35 milli at an angle of negative 149.69 equals 97.07 at an angle of 66.10. Okay, so we verified that these two currents add up to where it came from. Makes sense, so now we go back. to the next thing we have circled right here. How did we get this 5.161K? Well, we did the series combination. So this is the voltage across this. This is the current through this. So what are we bringing back to a series circuit? That's right, current. So we'll put 9.35 milliamps at an angle of negative 149.69. So this is the current for this 3K, for this 1.7, and for this 2K. So they all share, this, and this, share this current. These three voltages must add up to where it came from, which is here. So they have to add up to 48.24 at an angle of negative 150.58. So let's add the current. Let's multiply the current by each of these components and get their voltage. Okay, so we got 9.35 milli at an angle of negative 149.69. Okay, so then that times 3K is 28.05 at an angle of negative 149.69. Okay, and then we have that multiplied, by 2K is 18.70 at an angle of negative 149.69. Then we're going to multiply that. Z times 178.86 at an angle of negative 26.57 to get this voltage of 1.67 at an angle of negative 176.26. So now we have these three voltages. We need to make sure that these three voltages add up to where it came from, which is here, right? So let's do that. So we got 28.05 at an angle of negative 149.69 plus 1.67 at an angle of negative 176.26 plus 18.70 at an angle of negative 149.69. And these should add up to 48 at negative 150. And here we go. There's the proof it adds up. So now that they add up and it looks good, the last thing that we have to go back to is this that we have circled. How did we get this? Well, we did the parallel combination. You see why it's so important to write this down each step when you minimize the circuit. Okay, so we got this, which is here. This is the voltage across this. This is the current through this. It's going back to what type of circuit? Parallel. What's constant in a parallel circuit? Voltage. So this 1.67 at that angle is for here and here, right? Both of them. So let's put that down. So we got 1.67 at an angle of negative 176.26 here. Actually, I could just write it once. It's for both. Okay? So now we're going to get those two currents. And those two currents have to add up to where it came from, which is here. So those two currents have to add up to 9.35 at negative 149.69. So 1.67 at an angle of negative 176.26 divided by 400 at an angle of negative 90 gives me 4.18 milliamps, 4.18 milliamps at an angle of negative 86.26. So that's the current for this 400 ohms at an angle of negative. Then we do 1.67 at an angle of negative 176.26 divided by 200 ohms. Oops, I put 2,000. 200 is 8.35 milliamps at an angle of negative 176.26. Well, we need to make sure this is right, so this plus this has to add up to where it came from, which is this guy. So they have to add up to that. So let's do it. 4.18 milli at an angle of negative 86.26 plus 8.35 milliamps at an angle of negative 176.26. I hope I did that right. So I got 9.34 milliamps at an angle of negative 149.67. Close enough. So now everything worked out. You always verify to where it came from. So now we have voltage and current for everything. All right, bye.